You think you know what the speed of light is? 299,792,458 meters per second. Fast. Insanely fast. The fastest thing in existence. That's what they teach you. That's what everyone says. Light is fast. Okay, fine. But that's not what light speed actually is. That's not what it means. Most people think the speed of light is just a speed, like the speed of sound, or the speed of a car. Just a really, really big number. The universe's speed record. But that's completely wrong. The speed of light isn't a speed limit that was placed on the universe. It's not like some cosmic traffic law. It's something far stranger, far deeper. The speed of light is the structure of reality itself. It's how space and time are connected. It's the fabric. And once you understand what it actually is, everything changes. Everything you thought you knew about the universe, about motion, about time, it all falls apart and rebuilds itself into something completely different. Let me take you back. Let's start simple, not with light, with something you can see, something obvious. Throw a ball. The ball moves. You're on the ground, standing still. You throw a ball forward at 10 meters per second. Someone watching from the side sees the ball moving at 10 meters per second. Easy. Now get on a train. Train's moving at 20 meters per second. You throw the same ball forward at 10 meters per second. What does someone on the ground see? They see the ball moving at 30 meters per second. 20 from the train plus 10 from your throw. Speeds add. This is common sense. This is how the world works. You're moving. You throw something. The speeds combine. Everyone learns this. It's obvious. Now do the same thing with light. You're standing still. You turn on a flashlight. The light comes out at 299,793 meters per second. Fine. Now you get on a train. A really fast train. Let's say it's moving at half the speed of light. That's about 150,000 meters per second. Impossible to build, but imagine it. You're on this train. You turn on the flashlight pointing forward. Common sense says the light should now be moving at the speed of light plus the speed of the train, right? Just like the ball, you're moving forward, light is going forward, it should add up. So light should be traveling at about 450,000 meters per second. But that's not what happens. You measure the light. It's still going at 299,790,458 meters per second. Exactly the same. Wait, what? You think you measured wrong. So you do it again. Same result. You get the train going faster, 90% the speed of light. You shine the flashlight forward. You measure. Still, 299,790,35 meters per second. You're losing your mind now. You push the train to 99.9% the speed of light. Almost there. You shine the light forward. Measure. Still the same speed. The light is not going faster. It refuses to go faster. No matter how fast you move, the light coming out of your flashlight is always the same speed. This is insane. This breaks everything. Speeds are supposed to add. That's how motion works. But light doesn't care. Light doesn't add. It's always the same speed. Always. No matter who measures it. No matter how fast they're moving. This was the observation that broke physics. In the late 1800s, people kept measuring the speed of light. They measured it while the Earth was moving toward the sun. They measured it 6 months later when the Earth was moving away from the sun. The speed should have been different. The Earth's motion should have added or subtracted from the light's speed. But it didn't. The speed of light was always the same. Scientists were baffled. They invented all kinds of explanations. Maybe there's an invisible substance called the ether filling all of space, and light moves through the ether. So when you measure light, you're really measuring your motion relative to the ether. Maybe the Earth drags the ether with it. Maybe the ether is flowing. They built elaborate experiments to detect the ether. They measured light in every direction at every time of year, trying to find the motion of the Earth through the ether. Nothing. The speed of light was the same in all directions, always. The ether didn't exist. There was nothing to find. And then Einstein looked at this and said something radical. He said, what if the speed of light is just constant? What if that's a fact of nature? What if light always moves at the same speed for everyone, no matter how they're moving? And everyone said, that's impossible. If that's true, then time and space can't work the way we think they do. And Einstein said, exactly. Because here's the thing. If the speed of light is always the same, something else has to give. Speed is distance divided by time. If speed is constant and you're moving, then either distance or time has to change. Or both. And Einstein realized both. Time and space are not fixed. They're flexible. They bend. They stretch. They compress. When you move fast, time slows down for you. Not a little. Not as a trick. Actually, literally, physically slows down. Your clock ticks slower. Your heart beats slower. Your thoughts happen slower. From your perspective, everything seems normal. But compared to someone standing still, you are living in slow motion. And space contracts. The distance in front of you gets shorter. The faster you go, the shorter it gets. If you're in a spaceship traveling at 90% the speed of light, and you're heading toward a star that's 10 light years away, you don't measure 10 light years. You measure less. Maybe 4 light years. The space itself is compressed for you. This is real. This is not a perspective trick. This is not an illusion. This is what actually happens. Time actually slows. Space actually shrinks. And the amount they change is precisely the amount needed to make the speed of light come out the same for you as it does for someone standing still. Let me say that again because it's the most important thing. The universe adjusts time and space so that the speed of light is constant. Think about what that means. You're flying through space at half the speed of light. You turn on a flashlight. The light leaves the flashlight at the speed of light. But you're already moving at half the speed of light in the same direction. So how does the light get ahead of you? How does it still move away from you at full light speed? Because time slows down for you. Because space contracts for you. The universe literally warps itself to make the math work. Now here's where it gets even stranger. Let's say you want to go faster. You want to reach the speed of light. So you get in a spaceship and you fire the engines. You accelerate. You go faster and faster. 50% of light speed, 80%, 90%, 99%. You keep pushing, but something weird happens. The faster you go, the harder it is to go faster. It's not that your engines are weak. It's not that you're running out of fuel. It's that you, the spaceship, your mass, your inertia, it increases. The faster you go, the more you resist acceleration. At 90% of light speed, your mass is about twice what it was at rest. At 99%, it's about 7 times. At 99.9%, it's about 22 times. The closer you get to light speed, the more your mass increases and the harder it is to push you faster. And this is where the limit comes from. To actually reach the speed of light, your mass would become infinite. To accelerate infinite mass requires infinite energy, which you don't have, which nothing has. So you can't get there. You can get close, very close, 99.999999999%, but never quite there. Not because of engineering, not because of engineering, not because your spaceship isn't good enough, because the universe won't let you. The laws of physics prevent it. But wait, light reaches the speed of light. Photons do it. How? Because photons have no mass. Zero. Massless particles don't have inertia. They don't resist acceleration. They don't have this problem. And in fact, they must travel at the speed of light. They have no choice. From the moment they're created, they're moving at that speed. They can't slow down. They can't stop. They're always moving at light speed. And from their perspective, from a photon's point of view, no time passes. Ever. A photon emitted from a distant star and absorbed by your eye experiences 0 time. From its perspective, it's emitted and absorbed in the same instant. The photon doesn't experience time. Time doesn't exist for it. So why is the speed of light the limit? Why is the universe built this way? And here's the answer. The speed of light is not really about light. It's about the structure of space-time. Space and time are not two separate things. They're woven together. They're one thing. Space-time, and space-time as a geometry, a structure, and that structure has a built-in conversion factor between space and time. That conversion factor is the speed of light. Think of it this way. In everyday units, we measure space in meters and time in seconds. They seem like different things, but they're not. They're the same thing measured in different units, just like length and width. They're both distance, just measured in different directions. Space and time are both dimensions of space-time, and the speed of light is the conversion factor. It's like the exchange rate. 1 second of time equals 299,797 to 458 meters of space. That's the exchange rate. That's the geometry. And here's the key insight. You are always moving through space-time at a constant rate. Always. But your motion through space-time is divided between motion through space and motion through time. If you're sitting still, not moving through space, all of your motion is through time. You're traveling into the future at maximum speed, 1 second per second. But if you start moving through space, you have to divert some of that motion. Some of your motion through space-time goes into space, which means less of it goes into time. So time slows down for you. The faster you move through space, the slower you move through time. And there's a limit. If you move through space at the speed of light, you use up all your motion. There's none left for time. Time stops. You're moving through space at maximum and through time at zero. You can't go faster than that because you can't have less than zero motion through time. That's the wall. That's the limit, not a speed limit, a geometry limit. The speed of light is the maximum rate at which cause and effect can happen. It's the speed at which now propagates through the universe. It's the speed at which information can travel. Gravity propagates at this speed. Forces propagate at this speed. Everything that connects one point in space to another, one moment in time to another, it all happens at this speed. And we've tested this over and over. Particle accelerators. We accelerate electrons, protons, heavy ions to 99.9999% the speed of light. And guess what? The closer they get, the harder it is to push them faster. Their mass increases exactly as Einstein predicted. GPS satellites. They're moving fast. They're in orbit. Time passes differently for them than it does for us on the ground. If we didn't correct for this, if we didn't account for time dilation, GPS would be off by kilometers within a day. We have to program the satellites with Einstein's equations. Otherwise, they don't work. Muons, tiny particles created in the upper atmosphere when cosmic rays hit. They're unstable. They decay in about 2 microseconds. That's not enough time to reach the ground, even moving at close to light speed. But they do reach the ground. We detect them all the time. Why? Because they're moving so fast that time slows down for them. From their perspective, they live 2 microseconds in decay. But from our perspective, they live longer. They experience time dilation. So they make it to the ground before decaying. This is real. This is measured. This is not theoretical speculation. The speed of light being constant, being the limit. It's as well tested as gravity. And it all comes from one simple fact. The speed of light is the structure of space-time itself. It's not a speed, it's a geometry. It's the fabric of reality. And once you see that, once you understand it, you realize the universe is not what you thought. Motion is not what you thought. Time is not what you thought. It's all connected. It's all one thing. Space-time. And the speed of light is the key that unlocks it all. This is what Einstein saw. This is what he figured out. Not by building fancy equipment, not by doing complicated experiments, by thinking, by asking, what if the speed of light is constant? What does that mean? And following the logic and discovering that space and time are not fixed. They're flexible. They're relative. They depend on motion. And from that one insight, everything else follows. Time dilation, length contraction, mass increase, E equals mc squared, black holes, the Big Bang, gravitational waves. All of it comes from this one fact. The speed of light is constant. And here's the beautiful part. This started centuries ago. Newton figured out gravity. He watched the moon. He asked why it doesn't fall, and he realized it is falling, just missing the Earth. He wrote down the law of gravitation, inverse square law, and suddenly everything made sense. Planetary orbits, the tides, why the Earth is round, all of it explained by one equation, and then people used that equation to predict things. The moons of Jupiter, their orbits should follow Newton's law, and they did, almost. There was a discrepancy, 8 minutes. The moons were ahead of schedule when Jupiter was close to Earth, behind schedule when Jupiter was far. Something was wrong, but Romer, he had confidence in Newton's law. He said, the law is right, so what else could explain this? And he realized light takes time to travel. When Jupiter is close, the light takes less time to reach us. When Jupiter is far, it takes more time. So we see the moons earlier or later depending on how far away Jupiter is. And from that delay, from those 8 minutes, he calculated the speed of light. He found the speed of light by trusting Newton's law of gravity. One law leads to another. One discovery makes the next one possible, and this has been going on for 400 years. Newton to Romer to Einstein to particle physics to GPS to gravitational waves. Each discovery builds on the last. Each insight opens the door to the next. It's an avalanche, and we're still in it, still discovering, still learning, still uncovering how deep this goes. The speed of light is not just a number. It's the thread. It's the thing that connects everything. It's the structure of reality. And the fact that we can understand it, that we can measure it, test it, use it, predict with it, that's the miracle. That's the beauty of physics. Not simplicity, not comfort, truth.